Welcome to this explainer. Okay, so as an aerospace and defense policy analyst, I spend a lot of time tracking how our strategic capabilities are evolving. And for decades, our reach, whether we were looking upward into the stars or outward across our geopolitical borders, was strictly limited by human perception. We were the bottleneck, right? We had to manually respond to all the intelligence we gathered. But right now, we are crossing a massive threshold. In this explainer, we're going to analyze a really fascinating shift. We're going to explore how artificial intelligence is transforming from just a supportive background tool into an autonomous decision maker in some of the most extreme, high-stakes environments imaginable: deep space and terrestrial border defense.
Here's the roadmap for our dual frontiers journey today. First, we'll look at AI and space exploration. Second, autonomous border defense systems. Third, the AI sovereignty race. And finally, the ethics of automated decisions. We're actually going to trace how the exact same mathematics used in interplanetary discovery are applied to terrestrial geopolitics. Let's get into it.
The absolute crucial shift to understand here is this. AI is no longer just a data processing tool. It's an autonomous agent now, and it's operating in black swan, or highly unpredictable, environments. We are seeing a profound shift away from manual human control, and it's largely driven by massive data bottlenecks. Think about the petabytes of telemetry pouring in from space telescopes. Add in the impossible physical realities of these extreme environments, and it becomes physically impossible for a human operator to maintain total situational awareness over thousands of miles of remote borders, let alone millions of miles of deep space.
24. That is the communication delay in minutes between Earth and Mars as of 2026. Now put that into perspective. If a rover is navigating a crumbling Martian cliffside, it literally cannot wait 24 minutes for a human commander on Earth to evaluate the telemetry and push the brake pedal. By the time the signal reaches Earth, it's already over. Waiting for instructions is quite literally a death sentence for the mission. So true autonomy, it isn't a luxury anymore, it is an absolute baseline requirement for survival.
Section 1. AI and space exploration, or as we like to call it, the Cosmic Scout.
So, when we're hunting for exoplanets, what we're actually looking for is a transit. That's a tiny dip in a star's brightness when a planet passes right in front of it. And we're talking about a fractional dip of less than 0.01%. It's like finding a needle in a galactic haystack. Traditional algorithms constantly failed here because they just couldn't separate that faint signal from the background red noise of the instruments, or even the natural jitter of the star itself. But convolutional neural networks, they solve this mathematically. They treat the star's light curve like a 1D image. By applying multiple filters and using attention mechanisms, the neural network recognizes the specific U-shape of a planetary transit. It can scan a massive 10-year dataset and isolate a 3-hour transit window with just unprecedented accuracy.
And once a planet is found, AI steps up again for a process called atmospheric retrieval. This basically unfolds in 3 steps. First, detection. AI identifies a candidate planet sitting right in that habitable Goldilocks zone. Second is characterization. AI directs assets, like the James Webb Space Telescope, to perform spectroscopy. And then, step 3, inference. This is where we rely on Bayesian neural networks. This mathematical modeling calculates the absolute statistical certainty of chemical biosignatures. Basically, it's verifying life-sustaining markers like liquid water, oxygen, or methane significantly faster than human researchers ever could.
Now, deep space autonomy relies on some incredibly advanced mathematical tools. Take LiDAR SLAM, for example. It fires thousands of laser pulses a second to generate these dense 3D point clouds, which allows a drone or rover to actively dodge obstacles completely autonomously. And since there's no GPS out in deep space, these systems utilize visual odometry. The AI tracks unique topological features, measuring how they move across the camera frame to calculate 3D geometry and the vehicle's velocity. On top of that, terrain relative navigation lets rovers compare live orbital models with their live camera feeds, ensuring they land within mere meters of a target without waiting for Earth's instructions.
But AI isn't just looking for rocks and chemical biosignatures. It's also scanning for extraterrestrial technology. Standard algorithms are programmed to look for what we logically expect to see. Machine learning, however, utilizes unsupervised learning to scan massive radio frequencies for technosignatures. It doesn't just look for what we know. It actively hunts for anomalies that shouldn't naturally exist, signals that completely fail to match any known pulsar or quasar. It is proactively hunting for the unknown.
Pivoting sharply back to Earth, let's hit Section 2, Autonomous Border Defense Systems, the Silicon Sentinel.
We're going to see how these identical mathematical architectures are deployed right at our borders.
Historically, militaries relied on a linear, minutes-long manual command chain. You know the drill. A sensor detects an anomaly, a human analyzes it, command formulates a decision, and finally, an action is ordered. Well, in 2026, we have shifted to the AI kill web, an instantaneous, completely decentralized network. Neural networks seamlessly process sensor data from helmet cams, ground sensors, and drones in real time. If a border breach occurs, the AI automatically tasks the nearest drone swarm to intercept in literally milliseconds while simultaneously notifying a human. The human is no longer the tactical driver here, they are just the strategic supervisor.
Let's look at a real-world case study at a high-traffic modern border crossing. Static optical cameras are pretty easily fooled by low light or adaptive camouflage, but advanced gait analysis? That changes everything. It distinguishes specific individuals within massive crowds based entirely on their unique walking rhythm, skeletal proportions, and movement patterns. This biometric capability allows computer vision to instantly flag a specific person of interest among thousands. It renders conventional visual disguises completely irrelevant.
Modern borders essentially deploy multi-domain shields, or virtual fencing, powered by sensor fusion. You have LiDAR, thermal imaging, and seismic ground sensors, all feeding into a unified system to differentiate between a stray animal, random environmental movement, and a human intruder. And it does this with over 99% accuracy. At scale, this response is managed by swarm intelligence. Today, a single operator manages 50 autonomous drones that continuously communicate with one another to form an impenetrable, moving surveillance net over a designated sector.
And modern border AI doesn't just observe what's currently happening, it utilizes predictive threat analysis to anticipate what will happen. The AI continuously models historical crossing data and environmental factors to forecast high-risk windows. Then, it proactively reallocates mobile assets, shifting drones and ground patrols to vulnerable sectors long before an incident actually occurs.
Section 3, the AI sovereignty race, global geopolitics, and computational power. Let's look at the geopolitical implications of all this. We are entering an era where border security quite literally equals computational power. Major global powers, specifically the United States and China, are aggressively competing to amass H200 series processing chips. They are directly tying their data sovereignty to elite AI infrastructure, and this strategic digital divide is severe. Impartially speaking, nations that cannot access or afford this advanced AI architecture find their borders essentially transparent to those who possess superior automated surveillance capabilities. Your national data sovereignty is now strictly bound by your silicon. And this sovereignty race extends upward into low Earth orbit, presenting an objective, somewhat unsettling fact. The technological line between a cooperative repair satellite and a hostile interceptor satellite is practically non-existent. Think about it. An AI capable of autonomously and safely docking with a friendly satellite leverages the exact same mathematical functions required to dock with and disable an adversary's hardware. This dual-use capability is rapidly moving the arms race into low Earth orbit and escalating international political tensions.
Which brings us to our final resolution, Section 4, Ethics of Automated Decisions, the Accountability Gap.
When you look at this table, the leap is just massive. In just a single decade, we have seen an incredible leap in strategic capabilities across both domains. In 2016, securing borders and navigating space required intense manual intervention and post-event processing. By 2026, automated methods have replaced manual vetting entirely. We now rely on fully autonomous planetary landings, virtual AI fencing managed by swarms, and predictive pre-event threat modeling. The speed is unparalleled, absolutely, but it fundamentally removes the human from the tactical loop. And that removal creates profound humanitarian risks.
While an AI evaluates biological targets with 99% accuracy, the architecture natively lacks contextual empathy. A drone swarm cannot inherently distinguish between a malicious smuggler actively evading capture and a desperate refugee in distress unless it is strictly trained on those exact edge cases. This is exactly why ethical programming is absolutely vital. We have to hard-code these autonomous systems with strict de-escalation first protocols to ensure humane, automated border decisions.
Which leaves us with the ultimate black box accountability gap. Neural networks execute complex decisions that aren't always easily explainable. So if an autonomous defense system misidentifies a target and triggers a lethal or escalating response, where does the accountability actually fall? Is the programmer who curated the data, the strategic commander who deployed the swarm, or the AI itself? As we continue to deploy the Silicon Sentinel and the Cosmic Scout, we have to ask ourselves, what is the true cost of removing human judgment from the loop? Thanks for joining me on this explainer. As always, keep questioning the data and keep watching the frontier.